The next session will be dedicated to the Russian remote sensing system. We talked a lot about it. Roscosmos represents a large corporation with 80 companies operating under our roof, and I'm happy that today there is a considerable number of space and rocket industry representatives. They design satellites, they operate systems. One of them is NITP by Oleg Gomozov. It's a major processor of data. So I'd like to invite up on stage a colleague from Progress company. It's a space center. Maxim Klushnikov, first deputy director of Progress branch. He will tell us in more detail about Resurs-P. Good afternoon, dear colleagues. A team of co-authors led by Mr. Kirillny asked me to make a presentation about remote sensing system Resurs-P. Let's start with the task's structure. The structure has been designed based on request of federal authorities and municipalities. As you can see, all tasks have a fairly equal share except forests. Therefore, we deployed a federal remote sensing satellite system starting in 1996 as we launched 1 meter Resurs-DK, joined by others that followed. Valery Alexandrovich mentioned that. A noticeable role is attributed to RSC Progress. Here you can see satellites that are now disused. Actually, they're still up there. Resurs-P, Resurs IST-2D or Stork 2D. In the near future launches of Resurs-P number 4 and 5 should be made. Plus Resurs-PM, launch satellite and Observe-R with SAR system. Remote sensing system Resurs-P has 3 satellites and intended for high-res, wide swath and hyperspectral sensing for federal and private uses. This satellite addresses environmental, agricultural, mining, meteorology, and archaeological tasks. The structure of Resurs-P system includes the ground complex of command, control, receive, process, and distribution of information. The satellites with fairing, ground control complex. Satellites Resurs-P number 1, 2, and 3 are like twins. Number 1 and 3 are twins. Resurs-P is slightly different. They include the primary camera, Geoton L hyperspectral camera, wide field multispectral cameras complex KH-MSA, and Resurs-P number 2 also has Nucleon scientific instrument. So they were launched in 2013, 14 and 16 respectively. The main instrument of Resurs-P is Geoton L camera. This camera has GSD 0.7 and 2.1 meter in multispectral. The swath width is 38.6, review width 950 kilometers. Spectral bands, panchromatic, 6 narrow bands, and 1 extra infrared band that can be used to replace panchromatic. Thus, we have 8 spectral bands. Location accuracy with refined attitude data 5 meters and 15 without GS ground control points. This is Moscow City and Taliati. The second instrument on board Resurs-P is a KSM SA. It includes 2 cameras, high resolution and medium resolution cameras. High res camera is shown on this slide with the resolution with GSD 12 meters. In panchromatic mode, the swath width is nearly 100 kilometers, and medium resolution cameras 5 times larger, meaning it can do 60 meters and 120 meters in narrow spectral band, and the swath width is 450 kilometers. These are images from KSM. The third instrument on board Resurs-P is hyperspectral camera, developed by Zverevsk-Krasnogorsky Zavod and Optex. It has number of spectral bands, 96 to 216. Spectral resolution, depending on wavelength, ranges from 5 to 10 meters. Swath width 30 kilometers, and GSD is 30. And again, images from hyperspectral camera. Resurs-P can acquire data in different modes. First, spot mode, 28 by 28 count. Long strip mode, when it can shoot for 300 seconds, doing a very long strip. Stereo area, up to 115 kilometer, and large area, covering several strips, 133 by 317 kilometers. It can operate either geoton alone or jointly with KSM. The full swath can be made, or it can be split into different strips, and it can be transmitted to one of 20 ground stations. This is stereo imaging, strip, and platform modes. If we compare Resurs-P with foreign satellites, we'll see it's doing very well in terms of swath width. It outdoes the foreign analogs. It does pretty good on a number of multispectral bands. This is an example using the same scale from different satellites. You can compare how you can acquire images for large areas. There's very good efficiency of information delivery and acquisition capabilities. Let's not forget that it has 3 ground stations, and you can do 750,000 square kilometers. This is some statistical data on Resurs-P corroborating this account. The ground infrastructure helps complex system from different instruments. This is a pen-sharp imagery to deliver high-resolution color image. You can also generate DEMs. You can complex high-resolution and low-resolution images obtaining multispectral data, or high spectral with GSA, which is a new thing not available by other systems, at least when simultaneous imaging takes place. How do you gain from it? Well, it makes segmentation process easier. This is how GSA data is processed. There's a difference with and without geospectral data. On the left, it's GSA alone, and on the other, the quality is much better. The second part of the presentation is dedicated to data usage based on several examples. These are the key customers, mostly government. This is not a complete list of users. Some data from Resurs-P is used by Samara, a region we have close cooperation, so several examples of it I'd like to share. On the left hand side, it's Samara region's coverage with geotone L. About 80% was covered, and the same territory coverage using cache MSA, practically 100%. The data was used to respond to different tasks. A bathymetric map was generated. We analyzed and mapped chlorophyll propagation in the water. Also, we analyzed and monitored minerals production, gypsum in particular. We can see how the pit is growing. We also monitored illegal dumping of waste, analyzed traffic on roads in different conditions and different times of the year. Well, you've seen something like that today. The data was taken into account when developing road infrastructure of the region, and you can see how the Cloverleaf junction is being built. You know that World Cup 2018 will be co-hosted by Samara, so some sports facilities are being erected, in particular the stadium. You see a change over 1 year. And this data is also used for forestry. Different indices, including NDVI by hyperspectral cameral. Summing up, Progress created the constellation of 3 satellites of Resurs-P, which can provide daily review of Earth's surface with 0.7 meters in swath and efficiency 750,000 square kilometers. Quality of information is akin to foreign systems. In 2016 through 2025, Resurs-P is planned to be upgraded and launched. The KHMSA camera will be somewhat changed. There will be 2 high-resolution cameras installed. So they should be launched in the nearest future. The next ones to go are Resurs-P 4 and 5. Thank you. Thank you, Maxim. You mentioned stereo imaging. stereo imaging, what kind of performance or acquisition does it have? Can you acquire data while using equipment for other imaging as well? I think acquisition rate will be 4 times less than when stereo imaging is not used. KHM assay is oriented to image at nadir. Technically it is possible. If I understand correctly, if we try hard and strain, let's say we have 800,000 square kilometers, about a million. So if we do stereo imaging, we'll do 200,000, right? Yes, something like that. Are there any other remarks or questions? Maxim, Resurs-P aim, key features and characteristics, parameters. What are they? The one which will replace Resurs-P. The parameters will be similar to Worldview 3, the Chromatic 0.4 meter with 20 kilometer swath width, 8 narrow bands, and the second instrument substituting HMSA will do 120 kilometer swath with 5 meter GSD, and that expands opportunities for data processing. I understand that this equipment was commissioned by Resurs to do mapping 1 to 25,000. In fact, no. Somewhat different equipment was supposed to be designed and used. And HOK is a unit that has slightly different characteristics. Okay.